All right, for all those people that are here right now, starting class on a late start Wednesday, that's sad that like we start later, but less people show up on time. It's horrible. Anyway, all right, class.
Yes.
Miss Johnson, how you doing? Okay, good. All right, so chain rule. So we're doing derivatives, so we're now able to actually do the basic derivatives. Now we're going to make them crazy. So we're going to add some other weird stuff to it. And then power rule, chain rule, multiple. Okay, so, all right. Now, one of those people actually mentioned about the notation. This is called Leibniz notation. It looks like this. Okay, that's a Leibniz notation. And this right here is the other guy's notation. So the ones that you will actually see and understand, and we're going to actually have to do this one later on when we do implicit differentiation. You could do it like this, but everyone messes this part up. So the notation and actually putting everything in. So that's why I try and do this notation as often as possible when we're doing it, especially when we get to implicit notation. All right. So could I just expand this and then do it? I could. So I would take this third degree trinomial and multiply it 100 times, right? I could. Do I want to? Hell no. That's why the chain rule comes into play. So it's going to look like this. So we're going to say what is inside. So for this one right here, I'm going to say that u is all this right here. So u equals x cubed minus 4x plus 1. Okay? So now from there, I'm going to take the derivative of that. So that's going to now be my u prime, or my du for this one right here, but I'm going to call it u prime for the sake of here. So I'm taking the derivative of u, 3x squared minus 4. So I said all of this right here is u, right? So now my problem is now going to be y equals u to the 100. Now can I take that derivative? Say yes. So if I take the derivative of this now, this would be y prime is going to be 100 u to the 99. But from my formula, since I have a u, I substituted and called it a u. What that means is I'm going to do times this, or in this case, the du. So I have the derivative of my sub, and then I times it by my derivative of what was my substitution. So it's going to be times u prime. Okay, so let's put that in now. So it's going to be y prime is equal to 100. Now I'm taking the u out now. I'm putting the u back. So what was u? U was all this right here. So my parentheses, x cubed minus 4x plus 1 raised to the 99 times u prime. My u prime is 3x squared minus 4. So chain U rule is brilliant. It is one of those things that's going to help us, and it simplifies a lot of what we do. Questions so far?
What's the final answer?
That's the final answer. Did I substitute right here? So I substituted, so my formula says dy dx, so the derivative of the whole thing is derivative of this of, in terms of u, not the x, and then what I substituted for the x, I now have times that. Or in that case, it is right here, the derivative of my substitution. Okay, yeah, that's the u. And then times u prime. So that's what was inside there. And so I substituted with a u, and then it's times the derivative of the inside. So normally using u is actually a lot easier on this. I could actually rewrite it and actually do it a different way if you want. The whole equation to be this first part. Okay, then now do you understand right here I get a u prime at the end, right? And so since I go inside, the complicated part that's going to mess up everything is going to be this. So I simplify it to be just u. And so that made all this right here, because when I looked at the problem in the first place, it said I took all that to the 100th power. I could expand it 100 times. I don't want to do that. I don't want to do that. That's going to be very tedious and take forever. So to simplify that, I just called it all u. And then I could do this right here, right? After I took away the complicated part, and I just called it u, I could do that easily, right? Okay. The next thing after that, since I did that and I had u, then it's times the derivative of what I replaced it here, and that's this thing right here.
So u is just putting inside the parentheses, right?
Yes, the complicated part.
Why is it not just the 100 u to the 90 to power 99? Why is it just that?
Because we have a couple different things that we have to take the derivative of. So the derivative of all of this, right? I can expand this and actually to get this, but then I also have the derivative of the inside. Okay, the derivative of the inside right here is different than just u to that, right? Yeah, so there's this inside here is different than just doing this. The derivative of the inside. It goes outside then inside. Yeah, so we work our way from the outside inside, and sometimes we have multiple chains in these things. This one is not one with a multiple chain, but my complication is right here. We've just been doing the inside where x is just by itself, right? We'd only have an x. But now, what is the derivative of x by itself? 1. Okay, so 1 times the derivative is still just the derivative, isn't it? So that's not complicating anything. But this one will complicate it because the derivative of the inside now is 3.
So
yeah.
Pi doesn't matter.
No, because that is that a variable? No, pi over 4 is a constant in there. So remember, that is a number, and when we take the derivative, it has to do with my variable, which I have here. So now that's changing what I do because I have the derivative of the inside of the 3x minus pi over 4, and I have to also have the derivative of cosine. So I have 2 things that I have to take the derivative of, and that's where I get the chain. All right, so now, Blade, we go inside out, and so the complicated part of this would be my 3x minus pi over 4, right? So I'm going to say that is my u. Okay, u prime, it's going to be 3, so u prime
So will y just equal cosine u?
Okay, so now y equals cosine u, very good. Y prime equals negative sine of u times u prime. And then what do? Put it back, right? Let's put it back. Over 4, right? Times 3. So I could clean it up by put that 3 up front, but I'm still showing all my work and my answers there. Yeah. I know it seems kind of crazy because it's like everything coming out of nowhere for a lot of this stuff. Like, holy crap, where'd that thing come from? So we're taking a complicated and we're uncomplicating it by putting in u's instead for the complicated part.
I saw that you stopped right there. Do we have to like continue, or would that be an accepted answer?
That's accepted. You could have put the 3 in front, so it could have been a negative 3 sine of 3x over pi over 4, or 3x minus pi over 4. Sorry. All right. Let's see where we at here.
Wouldn't the u in this case just be x squared minus 1?
Yes, because why?
Invisible parentheses.
Because that's the complicated part, right? That's the complicated part, so we have an inside, outside. So u and what would I say after that? U prime. And what would my problem now look like?
Y equals e to the power of u.
Yep, e to the u. E to the u
And y prime.
times what?
Times y prime, which is 2x.
Times
2x.
u prime.
Oh, I mean.
Yeah, u prime. So I'm keeping everything in notation right now. Same notation, step by step. I'm actually showing all the work for these, so I'm not getting lost. If you notice, I'm not throwing in that 2x when I could. I'm still showing every step. So now the next step is I put it back in. So let's get rid of my u and my u prime. So it's y prime is e to the x squared minus 4 times u prime, which is 2x. So I can rearrange it and put the 2x out front, and that'd be the same thing. Is this getting a little bit more straightforward? Now that you understand what it is that we're trying to do? All right, what's a complicated part of the next one? 4e to the x. So I would say my u is 4e to the x U prime. Yeah. So y equals
Equals
sine of u.
y prime equals cosine of u times
Oh wait, times.
y prime equals 4 e to the x times cosine.
You're rearranging it now?
Yeah, I rearranged.
Okay, that's fine. 4e to the x times.
Cosine of 4 e to the x.
Okay. So it's not so bad. It's just it was super complicated at first, right? So walking our way through this. All right, and the trig rolls also. It's basically the same thing that we did. So if you forgot what the trig rolls were, it's on that slide. And I'm going to stop right here, and I want you guys practicing on today's assignment, the 5.1 or the 3.1. Okay, so I want you practicing on that. Practice doing all the the showing your work, so the substitution, and like, share, and subscribe.